So, today we're doing 3.5, row operations. Okay, right. Okay, boys and girls. So, today we're going to learn how to use our row operations and augmented matrices to solve systems of linear equations. Okay? Okay, so like we learned in B30, chapter 1.4, 1.5, we learned elimination and substitution and stuff like that, right? Well, now we're going to be able to use matrices to solve systems with two equations like that one there, or we're even going to go crazy and do one with three equations. There's three variables. So, our row operation, there's only three of them. Switch two rows, multiply or divide a row by a number, or add or subtract two rows. Some equations into a matrix. We'll notice we already have two systems, so that's like two rows. We have an X column, a Y column, and then our equal column. So we can write this out as 3, negative 2, negative 25, and 1, 5, 54. And now to make it an augmented matrix, and so we know where the equal sign is, you just draw a dotted line right here. All we have to do is put that as a matrix. Three by three. We still have the three columns. But we don't have to worry about that. We're not doing any multiplying. Yes, you have to draw the dotted line. So after we do a bunch of row operations and awesome stuff like that, we're going to want to get a matrix of a form where we have our first row, first column is 1, and then everything after that is any number. And then in our second row, it's going to go 0, then 1, and then whatever number. That we can get our answer. Just for fun. What's that? Because that's what we need to do to solve. Because it'll have something equals a number, so this will just be our y. Some number that can go through solve. Then it would be 0, 1, then we'd have 0, 0, 1. So, yeah, that's right. We're going to want this where we have this diagonal of 1s here. And everything on this side is 0. Everything on the other side could be whatever. Doesn't matter. A little confusing right now, but once we do get down here, we'll learn how to row. So, when we go to solve the equation that we have here, negative 25, and then 1, 5, 6. So we have this matrix, and we're going to want to solve it using row operations. So here where we have the 3, we want a 1. So the first thing we're going to do is switch row 1 and row 2. This is going through its own. So row 1 is going to stay the same. And we're going to divide by 3, so 3 divided by 3 is 1, negative 2 over 3, and negative 25 over 3. Now, I have these two ones here in the front, so I'm going to take row 3, and I'm going to subtract row 1. Okay, bro. Okay. All I did here, guys, I took row 2, I subtracted row 1. 1 subtract 1 is 0. Negative 2 over 3 subtract 5, negative 17 over 3. Negative 25 over 3 subtract 54, negative 187 over 3. So, this guy stays the same. Negative 17 over 3 times negative 3 over 17. 1. What's negative 187 over 3 times negative 3 over 17? 7 over 7. So what's 187 divided by 17? Is that anything? 11. So, now I have my matrix in this form here, right? We have we have this matrix, and we can write it again back into the equation. So we have here 1x plus 5y plus 54. Second row, we just have y equals 11. Yeah, here we have the answer for y. We already know what y is. How do we find what x is? Yeah, we put it into this equation. We have x plus 5 times 11. Yeah, so we have x plus 55. X equals negative 1. Where's the answer to that? So row 3 subtract row 1. My first row is the stay the same. What do we get in our third row? Get a 0 and a 0 and a yeah, so 1 subtract 1 is 0. Another 1 subtract 1 is 0. 0 subtract 1, negative 1. We'll go into row 3, subtract row 1. We'll go 0, subtract 1. And negative 4, subtract 0. That, because we need a positive 1, not a negative 1. So we're just going to multiply. We're going to go row 3 times negative 1. Now that we have that, we can write out our equation. Our first equation is going to be x plus y plus z equals 0. Then we'll have y minus z equals 2, and z equals 4. Right? That's just taking our matrix. We have an x column, a y column, what does that tell him? Yeah, and now we just got to solve for all of it. We already know what that is. Okay. One is a number. Oh boy. Now you're what is a zero number? Zero number, yeah. Okay, so we know what Z is. Next thing we want to do is find out what Y is. How do we do that? Y is 6. Y is 6. If we go Y minus 4 equals 2. Y equals 6. Then find X. Put it back in the first equation.